Okay, today I'm going to talk about naming esters. So, an important thing about naming esters is this really, you'll have an easier time naming esters if you understand how they're formed. So if you haven't looked at my lecture on esterification reactions, you should look at that. You shouldn't really attempt to be naming esters until you understand the esterification reaction, because it really depends on you being able to break it down into those parts. So in order to name an ester properly, we have to imagine that they have an alcohol part and an acid part. So just doing the generic form here, R2, R1, this right here, and in fact, this is what your book says. Your book says acid part. I'm going to say a carboxylate ion part, right? So I'm going to say, imagine this. Imagine breaking it right here. This R2 is what, if you're forming this ester through an esterification reaction, this is the part that is the alcohol without the hydroxyl group. And this part is the carboxylic ion, or carboxylate ion. Right? So if I were to break it here and put my charge here, this is my carboxylate ion. So imagine when you're naming it, the oxygen goes with the carbonyl part, and that's the ion part. So the way we're going to name it is we're going to, this is actually this is the only one I can think of. It's the only one I can think of that has the only IUPAC name that has two parts, that has a space and two different words. So we actually break it into two words. So the first word is the name for, if we pretend this R2 is just a substituent. So the first word is R2 as a substituent. And the second word is actually going to be the name of the rest if it were just a carboxylate ion. So let's work on this. So how we would do it, let me give you a real life example. So if we look at this, we're going to break this into two parts. We're going to break it here. So this part over here, and then this part over here. So the first word is going to be what I've done in blue, and we're treating it like it's a substituent. So as a substituent, that would be ethyl, and then the second word would actually be propanoate, as though it were the ion. Hopefully that makes sense. So it's as though it were the ion. So ethyl propanoate. So the first word describes the alcohol half, what used to be the alcohol part. So this is, and then this is the carboxylate part. So I think we can just jump right into some practice. So try naming these, and I'll show you how they work. All right. So this one, the upper right corner, or upper left corner, sorry, up here, we're going to name this part first. So this is butyl, right? 1, 2, 3, 4 makes it butyl, and then this part, as an carboxylate ion, would be ethanoate, right? Because it's just 1, 2, and if we imagine that as the ion, it's ethanoate, right? So butyl ethanoate. This one here, up in the upper right corner, this is just going to be, the first word will be methyl, and then the second word is methanoate. And if it's not clear from the way I'm writing it, there is a space between the two words. These are two separate words with a space between them. This one, propyl, propanoate, And the last one is a little more complicated, but this part is pretty easy. It's ethyl. But the next part we have to name as though it's an ion. So it's going to be, so this is carbon 1, 2, 3, 4. It's ethyl 2, 3, dimethyl. I didn't leave myself enough room. Let me start further over. Ethyl 2, 3, dimethyl butanoate. There you go. I'm not going to get super complicated with the alcohol part. You might see like an isopropyl or a sec-butyl or that sort of thing. You won't see anything more complicated than that. So an example of that might be this. Right? So this part over here, because this is being treated as a substituent, we don't number from the longest part of the chain. We just go 1, 2. We could call this 1-methyl, but it's actually just isopropyl. So it becomes isopropyl is the first word, and the second word is 4-chlorobutanoate, because there's a chlorine at carbon number 4. Hopefully that makes sense.